So, what if the next industrial revolution isn't about building cars or skyscrapers, but about manufacturing intelligence itself? It sounds like science fiction, right? But that's the bold vision we're unpacking today, straight from NVIDIA's latest annual review. We're going to go way beyond just faster chips and look at the blueprint for a totally new kind of factory, a new economy, and yeah, a completely new industrial age. And this quote from CEO Jensen Huang really sets the stage for everything. He's not just talking about the next product cycle here. He's framing this as a fundamental, once-in-a-generation kind of shift, the type of change that completely redefines how everything works. This is all about building the very foundation for an era that's going to be powered by AI. So, what's going to power this new industrial age? Well, it's not smokestacks or assembly lines, it's these, AI factories. At its heart, an AI factory is a new kind of data center built for one single purpose: to generate intelligence. And the analogy is pretty spot on. Just like a power plant turns fuel into electricity, an AI factory turns raw data into intelligence. And this gets us to the core of the revolution. The actual language of computing is changing. For decades, everything has been about bits and bytes, those simple on and off switches. But see, that's the language for retrieving information. This new world, the one that's all about generating information, well, it speaks a completely different language. Okay, so let's get specific. What is an AI factory? It's a whole new class of data center. Think about it. Traditional factories churned out physical stuff, like steel or cars. These new factories, they produce a whole new commodity: intelligence. They're built from the ground up to take in raw data and spit out answers, ideas, and even creative content. And what are these factories producing? Not bits, but tokens. And this, right here, is a super important idea. Think of it like this. If bits are individual letters, tokens are more like words, or maybe even entire ideas. They're the building blocks of meaning for an AI. A single token could be the word apple, a snippet of code, or a single note in a song. When an AI strings these tokens together, it's not just crunching numbers. It's reasoning, it's creating, it's communicating. And that makes tokens the real currency of this new intelligence economy. All right, so how are these factories actually built? What are the nuts and bolts? In this next section, we're going to pop the hood and take a look at the full architecture that's powering this entire revolution. And this slide, wow, it really gets at a huge shift in the company's whole identity. See, NVIDIA realized that to lead this revolution, they couldn't just keep selling parts, like graphics cards. No way. They had to design the entire factory. They've basically gone from being a parts supplier to being the master architect for the whole end-to-end AI data center. So here's how they do it. It's this full-stack approach where every single layer is built to make the next one better. It all starts with the Blackwell chips. That's the raw horsepower. Then, those chips get built into these massive supercomputer systems. But that hardware is useless without their CUDA software, which is kind of like the operating system for AI. And then, right at the top, they offer these prepackaged AI models called NIMs, which makes it way easier for anyone to actually deploy intelligence. It's the whole shebang, a complete solution for building an AI factory. And just to give you a sense of the sheer scale we're talking about, this is the heart of the AI factory, the GB200 NVL72. It is a 1.5-ton AI supercomputer. This isn't just a box of parts, it's a single massive integrated machine designed for one thing and one thing only: industrial-scale intelligence generation. So is this just some far-off vision? Well, the market is screaming no. This number, 114%, that's NVIDIA's year-over-year revenue growth. I mean, that's not just good growth, that's hard evidence that this industrial revolution is already happening. The demand for these AI factories isn't just growing, it is absolutely exploding. Okay, so we've got these incredible factories churning out massive amounts of intelligence. The next logical question has to be, what do we do with it? What's next? And the answer is taking all that intelligence out of the digital world and putting it to work in our physical one. And that next wave is called physical AI. We're talking about systems that don't just process data, but can actually see, reason, and act in the physical world. Think warehouse robots, surgical assistants, and of course, self-driving cars, machines that have to navigate the same messy, unpredictable reality that we all live in. But that is a massive challenge. I mean, you can't possibly train a robot for every single situation it might run into in the real world. Trying to collect that data is ridiculously expensive, it's slow, and in some cases, like testing a car's emergency brakes, it's just way too dangerous. The other option, simulation, just hasn't been realistic enough. And this creates this big roadblock that people call the simulation to reality gap. Which leads us to the billion-dollar question, right? How in the world do you train an AI for the infinite complexity of the physical world? How do you prepare it for things it has never seen before? And do it safely and effectively? And this is where NVIDIA's blueprint for physical AI really comes into play. Their solution to this whole sim-to-real problem, it's seriously ambitious. The answer to that question is as simple as it is powerful. You don't just give the AI a little simulation to learn from. You give it an entire universe to practice in. That universe is called NVIDIA Cosmos. It's what they call a world foundation model, which basically means it's learned the unwritten rules of our physical world, things like gravity, friction, momentum, by watching over 20 million hours of video. It isn't learning physics from a textbook. It's learning by just observing reality over and over again. And this is how Cosmos bridges that gap. Instead of trying to create fake worlds from scratch, it actually augments real-world data. So it can take this real dashcam video from a perfectly sunny day and ask, okay, what would this exact same scene look like in a blizzard? And then it generates a totally new, physically accurate video for that exact scenario. This means developers can create practically limitless training data from a small set of real recordings. And this is what finally closes that sim-to-real gap. It means autonomous systems can now be trained on a huge variety of conditions, day, night, rain, snow, you name it, without ever having to put a physical robot in danger. It's a game changer for accelerating development safely and at a massive scale. Okay, so let's zoom out and bring this all together. We have AI factories making intelligence. We have a blueprint for training physical AIs to operate in our world. The final question is, what does all this actually mean for our economy and for us? The vision here is for a completely new kind of workforce. You've got a digital workforce made of AI agents that can automate complex tasks, and then a physical workforce of robots. And the key idea is that these aren't just tools. The thinking is that they'll be like digital and physical employees that you can hire, train, and manage to work right alongside the human team. And we're not just talking about a couple of niche sectors here. AI applications are already sweeping across every industry you can think of, from speeding up drug discovery to optimizing financial markets to completely reinventing industrial design. The impact is going to be incredibly broad and incredibly deep. The scale of this economic transformation is almost hard to wrap your head around. I mean, we are talking about reshaping the entire 100 trillion global economy. The vision is for billions of digital agents to automate complex knowledge work, while millions of intelligent robots fill critical labor shortages in places like manufacturing and logistics. The end result? A massive global surge in productivity and economic growth. And all of this, it leaves us with one final and pretty profound question. As these new forms of digital and physical intelligence join our workforce and become a part of our daily lives, what does that change about our own role? What will it really mean to be human in the age of AI?